Hi everyone, we're doing ACT Review 11, multiple choice number 3 today. Start off with no calculator in number 1, and oops, that means a camera adjustment. Okay. Great. There we go. Okay. Number 1. Number 1 says if f of x equals e to the 2 ln of x, then f prime of 3. Well, using my log properties, I kick this back up here, and I get that f of x equals e to the ln of x squared. And e to the ln, they cancel each other, and so we just have x squared as f of x. So f prime of x is 2x, and therefore f prime of 3 equals 2 times 3, or 6, and that corresponds to choice A. Number 2. Total area between f equals x minus x squared and g equals x to the third minus x. So between 0 and 1. If I graph these, I get x minus, or 1 minus x. Here, downturn parabola. This one is f. And then here, if I pull out an x, I get x squared minus 1, which is there. And it's positive x to the third, so we look like this. There's g of x from 0 to 1. I just need to do top minus bottom, f minus g. Okay, so that's going to be the integral from 0 to 1 of x minus x squared minus x to the third minus x. Don't forget to distribute that to that dx. And so we get the integral from 0 to 1 of x minus x squared minus x to the third plus x dx. That's the integral of 2x. And so that's going to be x squared minus x to the third over 3 minus x to the fourth over 4 from 0 to 1, which is 1 minus 1/3 minus 1/4, or 12/12 minus 4/12 minus 3/12 is 5/12, and that's choice A. A for number 2. Okay, problem number 3. Graph of f is shown above, two semicircles. F prime of 1 will be the slope at 1, which means I need to write the equation of that circle and find the slope at that point, or that semicircle. So f of x, on this interval anyway, is square root of 4 minus x squared. Okay, and so f prime is going to be 1/2 4 minus x squared to the minus 1/2 times negative 2x. These 2's cancel, and so I get f prime equals negative x over square root 4 minus x squared. I want f prime of 1, so that's going to be negative 1 over square root of 3, or negative 1 root 3 over 3. So that's choice B. B for number 3. 4. Let's take a look at 4. For which value does f prime equal to 0? Well, f prime equals 0 when we have a 0 slope, and the only place in the picture I see a 0 slope is at x equals 0. And so that's at A. Okay, because this isn't a graph of f prime, this is a graph of f. Great. Number 5. The position of a moving particle. Position of a moving particle along a straight line is given by s of t equals t to the third plus 9t squared minus 27. Velocity at the time when acceleration is 0. So I need to find acceleration. So v of t is 3t squared plus 18t, and acceleration is 6t plus 18, and acceleration equals 0. 6t plus 18 equals 0, when t equals -3. And we want to know the velocity at this time, so let's plug a -3 into v. v of -3 equals 3. -3 squared plus 18 times -3. 9 times 3 is 27, minus 54 is -27. And so that's choice A for number 5. Number 5 is A. 6. The greatest integer function. Let's take a look at the graph of the greatest integer function. Open circle, 1, 2, 1, -1, -1. Okay, so we're concerned about as we approach 0 from the negative. Well, as I approach 0 from the negative, this function has a value of -1. And so I'm looking at the limit as x approaches 0 from the negative of 1 over int x. And that's the same as the limit as x approaches 0 from the negative of 1 over the limit as x approaches 0 from the negative of int x, which is 1 over -1 or -1, and that's choice B for number 6. 7. This is an FTC2 question because they give me a derivative and an initial condition. So if I integrate dy dx with respect to x, that should equal y of, I don't have to do that, I just have to integrate. Sine 3x minus 3 dx, the antiderivative, let's do it as a u sub, 3x minus 3 du over 3 equals dx. So sine u du over 3, 1/3 sine u du. That's 1/3 cosine, don't forget the negative, u plus c. And if we plug in a 1 for x, 3 minus 3 is 0. So u is equal to 0. No, I'm not going to do that. It's just going to confuse you. 1/3 3 cosine 3x minus 3 plus c. Okay, now let's use our initial condition, which was y of 1 equals 7. So if I plug in a 1 here, 3 times 1 is 3, 3 minus 3 is 0, cosine of 0 is 1, and 1 times -1/3 is -1/3. So 7 equals -1/3 plus c. c equals 7 1/3, or 22/3, which means our equation would be -1/3 cosine 3x minus 3 plus 22/3. Oh, look, I left out the plus 4. I hate my life. Sorry, going too fast this morning. There's a plus 4 up here. I know, you all said it, and I didn't hear it. But I figured it out eventually. Okay, so this is sine u plus 4 plus 4. Actually, I'm going to split this into two integrals. Integral 4 dx. Integral 4 dx du over 3 plus 4x. So we've got 4x plus minus 1/3 cosine 3x minus 3. This is what y equals, and if we plug in a 1, we're supposed to get 7. So 7 equals 4 minus 1/3 plus c. So 10/3 equals c. And so that looks like choice B. B is our answer to number 7. 8. Oh, 7a. Antiderivative of x squared plus 1 squared is what? Okay, so the antiderivative of this. Well, I think the easiest way for me to do this, since I don't have an x out in front to do a u sub with, would actually just be to FOIL this out. X to the 4th plus 2x squared plus 1, and then find the antiderivative of each piece. X to the 5th over 5 plus 2x to the 3rd over 3 plus x plus c. That looks like choice D. 8. What is the equation for the line tangent to? So y equals tangent inverse x, and we want when x is square root of 3. Okay, so if I plug in a square root of 3, I'm supposed to know the inverse tangent of root 3. And this is without calculator. And so here's how we're supposed to do this. We're supposed to say, okay, this input on inverse tangent is an output on regular tangent. But Mr. Kukla, I don't know when tangent is equal to root 3, let alone root 3 over 1. Yes, but what about sine over cosine equals root 3 over 1? Mr. Kukla, there's no root 3 on the unit circle. Well, there is a root 3 over 2. And so when is sine equal to root 3 over 2 and cosine equal to 1/2? And that happens at pi over 3. So my output here is pi over 3 because this output gave me an input. And so I have this ordered pair, pi over 3 root 3 on the tangent function. When I switch those, I now have root 3 comma pi over 3 on inverse tangent. So there's the point. The slope comes from taking the derivative here. So let's take the derivative of this and get 1 over x squared plus 1. Our x value is root 3. So y prime of root 3 is going to be 1 over root 3 squared plus 1, which is 1/4. So then y minus pi over 3 equals 1/4 x minus root 3. That one looks like 1/4. That looks like choice E. Okay, E for number 8. Number 9. 9 says f is differentiable. F of 0 equals -1. F of 4 equals 3. Well, we know because f is differentiable that f is also continuous. And with IVT, we know that we have to pass through all the y values from this y value to this y value. So we're going to pass through 0 and we're going to pass through 1. So we've got 1 there. 1 is f is going to pass through a y value of 0. Good. That's nice. Now, these next two choices are derivatives, and that's because they told me here that f was differentiable. Therefore, I know it's continuous, and so MVT applies. And so I can say f of 4 minus f of 0 over 4 minus 0 equals f prime of c. So what do we get then? This is 3 minus a minus 1 over 4, which is 1. F prime at some point equals 1. And that's choice 3. Now, f prime can't equal 0 because this didn't equal 0. So I only have 1 and 3. and that corresponds to choice D for number 9. What about number 10? Suppose that f equals x to the fourth, f equals x to the fourth plus ax squared. Then f prime is going to be 4x to the third plus 2ax. And I want to know when f prime equals 0, because I'm looking for mins and maxes. So I'm going to take out a 2x here and be left with 2x plus a. 2x squared plus a. All right. Now, when x equals 2, I want to have a minimum. Okay, so let's plug in a 2 here. 2 squared is, oh, and I'm setting this equal to 0, and so 4 doesn't equal 0. Don't worry, because we only want this one. We want 2x squared plus a equal to 0 when x equals 2. So we've got 8 plus a equals 0, or a equals negative 8. Here's my f prime. Here's my a value of negative 8. We want this to be a minimum. Let's see what happens when we plug in. And so remember, we're plugging in 8. We're plugging in numbers to the left and right of this expression. This is our f prime at 2. So if I plug in a 0 for a, I get a positive. And if I plug in a negative 10 for a, I get negative 2 times 4 is negative 8, and that's negative. So I do have a min at negative 8. I kind of knew that was coming, but I just wanted to confirm my work. Choice B for number 10. Okay, number 11 is the integral from negative x to 0 of sine x over 2 plus cosine x dx. The first thing I'm going to do is pull out a negative and flip these. Negative x, whoa, oh, negative pi. I guess I don't have to flip those. Negative pi to 0. Okay, so this is a u sub, where u is 2 plus cosine of x. Du equals negative sine x dx. So negative du equals sine x dx. So then this integral can be rewritten as 1 over u times negative du. And that's going to be negative ln of u. Now, we want to evaluate from negative pi to 0. So I can take these and plug them in here and use some u-bounds. Let's practice that. If I plug in a negative pi, cosine of negative pi is negative 1, plus 2 is 1. And if I plug in a 0, cosine of 0 is 1, plus 2 is 3. And so this is going to be negative ln of 3 minus a negative ln of 1. ln of 1 is 0, so all this goes away, and I just have negative ln of 3, which is choice A for number 11. Let's take a look at 12. Number 12 says, what's the x-coordinate of the point of inflection for f? And f is given as this polynomial function, 4x to the third plus 6. So f prime equals 12x to the third minus 12x squared. And then f double prime equals 36x squared minus 24x. I want to know when f double prime equals 0. So I'm going to factor out a 12x, leaving me 3x minus 2. And I get 0 and 2/3. Do I have sign changes? Well, I don't have any multiplicities of 2, so I think I have sign changes everywhere. But let's just check. Let's plug in a 1, and I get positive. And let's plug in a 1/3, And you may say, why 1/3? Well, 3 times 1/3 is 1. 1 minus 2 is negative, times positive is negative, and I'll plug in a negative 1. I get negative 5 times negative 12 is positive. I do have sign changes in f double prime twice, once at 0 and once at 2/3, and so choice D is my answer to 12. Okay, 13, integrate an absolute value. No way am I doing that by hand. This is a situation where I appeal to the graph. So let's think about this. This is absolute value shifted right 2 and flipped upside down and shifted up 2. So there, 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 and we're going from 1 to 3. Which is this trapezoid times 2. Okay, in order to find the area of this trapezoid, I'm going to need to know this y value. I already know this one is 2. Let's plug a 1 into this function. 1 minus 2 is negative 1. Absolute value of negative 1 is 1. 2 minus 1 is 1. So then, 1/2. This is a distance of 1 and 1 plus 2. Now remember, that's just this trapezoid. I've got this other one over here as well, so let's multiply that by 2. And so I get 3 is the value of that integral. 3 is the value of that integral, and that is choice D for number 13. 14. 14 says y equals 3x plus 1 over x minus 1. And what's dy dx? Dy dx, I need the quotient rule. Low d high minus I d low over low squared. Okay, so 3x minus 3 minus 3x minus 1. The 3x's cancel, and I have negative 4 over x minus 1 squared. Negative 4 over x minus 1 squared is choice A. I'm moving on to problem 15. 15. Okay. Find the derivative with respect to x of the integral from x to 2 of ln of 1 plus t dt. Well, remember, FTC1 works when I have a constant here and a variable here. So I'm going to pull out that negative before I take the derivative. 2x ln 1 plus t dt. And now when I take the derivative, this goes here, and I get ln of 1 plus x times the derivative of that. Don't lose that minus out in front. So we're looking for negative ln x plus 1, and that's choice C. All right, 16. 16 says f prime equals negative 5, x minus 3 squared, x minus 2. So if I graph this, I've got 2, I've got 3. This is an x to the third, but it's a negative x to the third. So it starts high, and don't forget the bounce at 3. Okay, and this is f prime. All right, so f prime has a max at 2, has an inflection point and an inflection point. Max at 2, inflection point at 3, and at this guy here. So what do we say here? Local min. No, I'm going from positive to negative. A local max? No, not choice B. An inflection? No. A local max and an inflection point at 3. Yes, that's going to be E for number 16. Yes, I know there's another inflection point, but they were only asking about these things. And that's choice E. 17. 17 says f equals e to the x root 3 cosine x on 0 to 2 pi. On what intervals is f decreasing? So I want f prime which means I have to use the product rule. I get root 3 e to the root 3x cosine x plus e to the root 3x times the derivative of cosine is negative sine. So minus sine x. I'm going to factor out an e to the root 3x, and I'm left with root 3 cosine x minus sine x. This is always positive for the purposes of finding critical points. This will never be equal to 0, so I'm really only concerned with when this equals 0. And this is root 3 cosine x equals sine x. Oops. Root 3 cosine x. If I divide both sides by cosine x, we've seen this one already today. This one's this. And so we know that x equals pi over 3. Okay, so pi over 3 is our only critical point on 0 to 2 pi. Oh, wait a second. Couldn't this happen if they were both negative? And that would be in third quadrant. What would that value be? Pi over 3, 4 pi over 3. Okay, let's test some values then. How about 0? How about pi? How about 2 pi? So sine of 0 is 0, cosine of 0 is 1, so we have root 3 minus 0, that's positive times positive is positive. We plug in a pi, that's still 0, that's now negative. Root 3 times positive. And if we plug in a 2 pi, that's exactly the same as when we plugged in 0, and so we get positive. And so we're looking for when is f decreasing, and so that's between pi over 3 and 4 pi over 3. And that seems to be choice B. Choice B for number 17. Okay, how about number 18? 18 says the integral from 0 to b of f of x dx equals 3a. Graph of f is symmetric about the origin. Well, so remember with origin symmetry, this area and this area are the same but opposite SIGNs. So if I integrate from negative b to b of f of x, that's just going to be 0 because this area is going to cancel that area. This area will be 3a, this will be negative 3a, and I'll end up with a value of 0. So A is my answer to number 18. How about 19? Which of these functions grow at different rates? At different rates. Okay, so I see here two polynomial functions. Limit as x heads to infinity of x to the fourth over x to the third. That's infinity over infinity, so I use L'Hopital's rule. Infinity 4x to the third over 3x squared. Still infinity over infinity. Better use L'Hopital's rule some more. And so I get 12x squared over 6x. Uh-oh, still infinity over infinity. Limit as x approaches infinity of 24x over 6. And that's infinity, so the one on top grows faster. These grow at different rates. All the others must grow at the same rate. And if we had time, I would go through each of them and show how we ended up with the same value. Or constant when we did this limit. Remember, if we get infinity, the one on top grows faster. If we get 0, the one on the bottom grows faster. And if we get some non-zero constant, then they grow at the same rate. So that means our answer here is choice A. Those are the ones that grow at different rates. 20. 20 says, what's the integral of secant squared 2x dx? So that's going to be tangent to x with a 1/2 out in front. If you're not sure about that, go with u equals 2x, and you'll see that du over 2 equals dx, and that's where that 1/2 is coming from. This is choice A. A for number 20. Okay, 21. 21. Y equals sine x, y equals cosine x on 0 to pi over 2, and the x-axis. Okay, so let's draw this. Here's a sine graph to pi over 2. Here's a cosine graph to pi over 2. 0, 1. And here's the x-axis, and we're looking for the area. Well, I have to split this into two integrals if I'm doing top minus bottom. I want the integral from 0 to pi over 4 of sine x dx plus the integral from pi over 4 to pi over 2 of cosine x dx. That looks like choice E, question mark? I think that's choice E. Sorry, I'm very squinty right now. That appears to be choice E for 21. And next we seem to have 38 squeezed in here. If f of x plus y equals f of x times f of y, what can we say about the, and the limit as x as h approaches 0 of f of h minus 1 over h equals 6, then what can we say about f prime of x? Okay, well, I'm going to say, since I know this thing, and I see these h's, I'm going to say f of x plus h equals f of x times f of h. And if I go back to my limit definition of the derivative, the limit as h heads to 0 of f of x plus h minus f of x all over h, I can replace this f of x plus h with this stuff. So this is going to be the limit as h heads to 0 of f of x times f of h minus f of x all over h. So all I did was replace this with what it was equal to. Now I see I can factor out an f of x here, and so we're going to have the limit as h heads to 0 of f of x times f of h minus 1 over h. Well, they told me that that was equal to 6, so this is just the limit as h heads to 0 of 6 times f of x, which is 6 f of x, and that corresponds to C, choice C for number 38. Okay, 22. 22 says, what is the value of the integral from 0 to 6 of f of x dx? So I count an area of 3.5 above the x-axis, and below the x-axis I have 2. I add those two areas together and I get 1.5, which is choice E. Because they asked for the integral, not the total area. If they had asked for the total area, I would have gone with 5.5. All right, number 23, the integral from 1 to k of x to the minus 1/2 equals 4. Then k equals what number? Well, let's do this antiderivative. This is going to be 2x to the 1/2 from 1 to k. And that's going to be 2 square root of k minus 2 square root of 1 equals 4. Well, the square root of 1 is 1, times 2 is 2. I add 2 to both sides. I have 2 root k equals 6. I divide both sides by 2. K equals 3. Square both sides, and we get k equals 9. K equals 9 is choice C. Okay. Choice C for number 23. How about 24? 24 says f of x equals e to the x root 3 is defined on... Oh, we did that one already. We did that one already. We said it was between. We said it was b. I guess that's a repeat. Don't have to do that twice. 25. The graph, which is this slope field. Well, I see that when x equals 1, dy dx equals 0, and I see when y equals 2, dy dx equals 0. So let's look at these choices and say, oh, when x equals 1 or when y equals 2, I'm going to have a 0 slope. So that's choice A. 26. If y equals e to the 8x squared plus 1, then the derivative y prime is e to the stuff times the derivative of stuff. 16x e to the 8x squared plus 1 is choice C for number 26. 27. At what point on the graph is the tangent horizontal? X e to the minus 2x. So I need to know when y prime equals 0. This is the product rule, 1 times e to the minus 2x plus x times negative 2 e to the minus 2x. Factor out an e to the minus 2x from both of these, and we get 1 minus 2x. There's y prime. This is never equal to 0. This is equal to 0 when x equals 1/2. So at 1/2, at what point is the tangent line horizontal? Well, I got the 1/2, and it's the only one with a positive 1/2. Oh no, there's another one. That's what the slope would be, is my guess. But let's try plugging our 1/2 in here. We get 1/2 times e to the minus 2 times 1/2, which is 1/2 times e to the negative 1, which is 1 over 2e. And so yes, choice D is our answer to 27. What about 28? 28. What is the area enclosed by the y-axis, the x-axis? What is the area of the shaded region? Okay, well, so I want the area of the rectangle, which is 2 pi times 2, minus the integral of 2 sine x from 0 to pi. Okay, the integral of sine from 0 to pi, that's going to be, oh, it's negative sine. So plus 2 cosine x from 0 to pi. And if we plug in a 0 there, we get, oh, let's plug in the pi there first. 2 times negative 1 minus 2 times 1. And that's going to be minus 4. So 4 pi minus 4. 4 pi minus 4 is choice B for number 28. We've got number 45 sideways here. Let's take a look at that. 45 says f is differentiable with f of 1 equals negative 3 and f of 5 equals 4. Which of the following must be true? Well, with intermediate value theorem, we know that on 1 to 5, we must pass through all the values from negative 3 to positive 4. And I don't have that. F equals 0. F equals 0. Yes, I know that A must be true. And can I say anything with mean value theorem? Well, let's just check mean value theorem. F of 5 minus f of 1 over 5 minus 1. So that's 4 minus a minus 3 over 4, 7 over 4. Oh, I got E, and A. Oh, no, 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 not A. F of K equals 0 must be true. F of 0 equals K? No, I don't know that at all. I just know choice E then. E is the mean value theorem choice for number 45. Okay. Let's see. 29. 29 says x plus sine y equals ln of y. We want to know dy dx, so 1 plus cosine y. Don't forget to take the derivative of the inside cosine function with respect to x, and the derivative over here is 1 over y times dy dx. So let's move all the dy dx stuff to one side. 1 over y dy dx minus cosine y dy dx. And we'll factor out a dy dx, and we'll have 1 over y minus cosine y equals 1. And so 1 over 1 over y minus cosine y equals dy dx. Did they make a common denominator? They sure did. So this is going to be this, and then I can write that as 1 over 1 minus y cosine y over y. I do the flip and multiply, and I end up with y over 1 minus cosine y. So y on top, 1 minus y cosine y on the bottom, and that's choice E for number 29. Okay, 30. 30 says, if y equals sine of x minus sine x, luckily this is with calculator, smallest possible value for which the tangent line is parallel to the x-axis. Well, that's the x-axis, and that has a slope of 0, so I want to know when y prime equals 0. So let's get our calculator going here. So we've got sine of x minus sine x, and I don't need that turned on, but I want the derivative of that, y1, comma, x, and smallest positive value, yes, so I'm going to change my window 0 to 5, and my y value is negative 1 to 1. Make sure that I'm in radians and graph. Okay, that looks like the first one, unless that we're counting 0. No, we're not counting 0, because 0 isn't positive. Okay, second, calculate 0. Doink, doink, doink. And I get 2.310, which is choice B for number 30. Okay, 31. 31 says f of g of x equals x for all x. Hey, I don't know if you remember, but I remember from Algebra 2 and Pre-Cal that when I compose f and g and I get x, that tells me that f and g are inverses of each other. F and g are inverses of each other. So if I know that f of a equals b, then I know that g of b equals a, because g is the inverse of f. and I know that f prime of A equals C, then g prime at this inverse point must be the reciprocal of that slope. Which of the following is true? G prime of B equals 1 over C is choice C. Okay, C for number 31. 32 says depth of the water H is negative cosine pi t over 12 plus 4. And what do we want to know? The average depth of the water. So I want the average value of this function from noon to 3, 0 to 3, negative cosine pi t over 12 plus 4 dt. Okay, so I'll pull out my calculator and I'll do 1/3 times the integral of negative cosine pi x divided by 12 plus 4 comma x comma 0 comma 3. And I end up with 3.0996, which is choice B. B for number 32. Okay, 33. No, 41. How surprising. Which of the following could be the graph of f of x if this is f prime? So I see this f prime graph, and I see that f prime is always above the x-axis. So f must always be increasing. But I see f prime goes from increasing to decreasing. So I know that there's an inflection point somewhere. So increasing, always increasing, but concave up and then concave down. And here I have always increasing with concave up to concave down. So choice C is my answer for number 41. 42. Oh, no, 36. 36 says, at which point in the graph shown above can both the first and second derivatives be negative? Okay, so the first derivative is negative at C, and the second derivative is negative at C. I was looking for decreasing and concave down, and that's the only place where I have decreasing and concave down. 37, the total area bounded by y equals sine of 3x and y equals x. So I've got some sort of function like this, and I'm looking for this area. So I need to find this point. Let's use our calculator strategically to figure that out. We've got y equals x and y equals sine of 3x. And I want my window to be 0 to pi divided by 2. And I don't need any negative values. But I don't know if this is... Nope, sine doesn't go higher than 1. Okay, y equals x. And second, calculate intersect. Bump, bump, bump. And we get 0.7596208. So I want the integral from 0 to 0.7596208 of sine 3x minus x dx. Please don't try and do that by hand. Just come over here and do it all on the calculator. Second quit, math, integrate sine of 3x minus x, don't forget to close that parenthesis, comma x, comma 0, comma 0.7596289, and we end up with 0.262. 0.262 is choice B. B for number 37. On the side, we have 38 and 39. Let's take a look at 39, the region enclosed by the graphs 2 ln of x, 2 ln of x, and y equals 2. Y equals 2. Y equals 2, and x equals 1. So we want this region rotated about the x-axis. Okay. And it looks like they're using washers. Our little r is the y value called 2 ln of x. So little r squared is 4 ln of x squared. And big R is a constant 2, so big R squared is 4. And so we'd have the integral from 1 to e with a pi out in front of 4 minus 4 ln squared x dx, and that looks like choice E. E for number 39. Okay, last page, number 42. 42 says radius of a sphere increases, so I know that dr dt equals 2. And here they're saying, what is the rate of increase in volume? They want dv dt. And so we've got v equals 4/3 pi r cubed. Take the derivative of both sides with respect to time. 4 pi r squared times dr dt. Remember, you have to take the derivative of that inside r function with respect to time. And we can plug in what we know. We know, when the volume is 40. Okay, so 4/3 pi r cubed equals 40. And that's r cubed equals 30 over pi. So 30 divided by pi raised to the 1/3 power. So r equals 2.121, 2.121568836. Okay, that's going in here for r. I need to square that number. I need to multiply that by 4 times pi, and then I need to multiply that by r dr dt, which was 2. And so I get 113.123, which is choice D, 113.123 centimeters cubed per minute. Okay, 43. Let's take a look at 43. 43 says, suppose f and g are continuous functions. We've been given a bunch of information. Positive 3 to 7 of g equals 6. 3 to 7 of h equals 2. And the last one was 3 to 4 of h equals -4. So which of the following must be true? Okay, so they tell me the integral from 4 to 7. Well, I know the integral from 3 to 7 of h minus the integral from 3 to 4 of h will be the integral from 4 to 7 of h, right? Because if I have 3 to 7 minus this, I'm left with this, 4 to 7. So they tell me that this is 2, they tell me that this is -4, and so that equals 6, so Roman numeral 1 works. What about, I don't have any property for the product of integrals, so I can't say anything about that one. But let's take a look at Roman numeral 3, g the integral from 3 to 7 of g plus 2 is going to be the integral from 3 to 7 of g plus the integral from 3 to 7 of 2. We know that b minus a times the constant, so we've got 7 minus 3 times 2, or 8. And then here, we know that this value is 6, and so I get 6 plus 8 is 14, and that checks out as well. And so 1 and 3 only. No product property. I don't have a product property. I don't think I have a product property. I'll go look that up. 44. Okay. I know I can do product of limits, but product of integrals? It just doesn't seem right to me. All right. 44. 44 says dy dx equals sine x over x. Y of 1 equals 4. What's y of 2? So I know that y of 2 minus y of 1 equals the integral from 1 to 2 of sine x over x dx. So I know that y of 2 equals 4 plus the integral from 1 to 2 of sine x over x dx. So we pull out our calculator and we do 4 plus the integral of sine x, close parentheses, really important, divided by x, commas 1, comma 2. Okay. And I get 4.659. That's choice D. D for number 44. Well, look, here's 33. I wondered when it would show up. 33 says two differentiable functions are shown. F prime and g prime are shown. What is the value of the limit as x heads to 2 of f of x plus 7 over g of x plus x minus 1. Okay, so I want to plug in a 2. F of 2 is negative 7 plus 7 is 0. G of 2 is negative 1 plus 2 minus 1, which is 0 over 0. So I use L'Hopital's rule. X approaches 2 of f prime over g prime plus 1. So now I plug a 2 into the primes, and I get 5 over negative 2 plus 1, or negative 5. And that's choice C for number 33. 35 says particle moves in a straight line. Velocity is given by 5 minus e to the t. Total distance the particle travels from 0 to 3. So I'm going to be smart and just do the integral of absolute value from 0 to 3. I'm not going to worry about graphing this function and finding where velocity goes negative or positive and writing two integrals here. I can write this as one integral with absolute value. So math integral absolute, math number absolute 5 minus e to the x, close the absolute value, comma x, comma 0, comma 3. And I've got an argument error. I need a parenthesis here, maybe? How many do I open? Oh, I opened, and now I need to, what? No. What? F int, there's the function, comma x, comma 0, comma 3. What don't you like about that? Oh, I didn't close the, I see, there it is, parentheses. It's always a parenthesis. 12.180, and that corresponds to choice D. And finally, number 40 on the side. Number 40 on the side, use trapezoid approximation with 3 equal subintervals. Oh, so my subinterval width is 1. That makes it really nice. So we can do 1/2 the subinterval width, 1 of base 1 times 0.14, 2 of plus 2 of 0.21 plus 2 of 0.28 plus 2 of 0.36 plus 2 of 0.44 plus 1 of 0.54. Okay, so 0.14 plus 2 times 0.21 plus 2 times 0.28 plus 2 times 0.36 plus times 0.44 plus 2 times, no, only 1 times, 1 times 0.54. Okay. And then I want to multiply all of that by 1/2. 1.63 is not here. Oh, because they only wanted from 2 to 5. 2 to 5. I think that's it. Nope, I only need one of these and one of these now. All right, reading the problem, it helps. Read the problem. 0.21 plus 2 times 0.28 plus 2 times 0.36 plus 0.44. And don't forget to divide that by 2. And we get 0.965, and that's choice B. Okay, that's the end, but I'm gonna go back and just confirm that we don't have an integral property that deals with the product of integrals for number 43. Okay, so integral properties. There we go, integral properties. No, that's the fundamental theorem of calculus. I would have thought it was before that. Definite integrals, yeah. There we go. No. Oh, come on. There. Do I have a constant multiple? I have 0. I have order. I have sum and difference. I can add 2 integrals together. I've got max, min, and dominance. I do not have. So I was correct with number 43. We don't have a product with product of integrals. It feels very product rule-y. It feels very integration by parts. Okay. Well, I hope this was useful, and I hope you have a great day.